Hello friend, I am Samadi back to a new tutorial video regarding IS456-2000. So last video we talked about these world 32 number clauses. So today I will start from the footing, and the last video I talked about the stair also. So now today we talk about the footing. That is the clause number 34. In case you have missed my last video, then you will find playlist in the I section, so just check out. So in footing 34.1 is general. Footing shall be designed to sustain the applied loads, moments and forces that induced reaction, and to ensure that any settlement which occur shall be as nearly uniform as possible, and the shape bearing capacity of the soil is not exceeded. So in this point they talk about basically three aspects. Aspect number one, footing can resist force, moment, as well as some induced reaction. Point number two, settlement may occur, but definitely minimum that should be uniform, not like this kind of settlement, not like these kind of settlement. So this should be this kind of settlement. And third point, the shape bearing capacity of soil is not exceeded. Shape bearing capacity sigma s or SBC, shape bearing capacity, which we learned how to calculate in my soil mechanics playlist. So just go and check out. So definitely not exceed this value. In next 34.1.1, in slope stepped footing, the effective cross section in compression shall be limited by the area above the neutral plane, and the angle of slope or depth and location of step shall be such that design requirements are satisfied at every section. Definitely, sloped and stepped footing that are designed as a unit shall be constructed to assure action as a unit. So maybe there are some step as well as slope, so treat as one unit. And here that is here. Next is 34.1.2, thickness at the edge of footing. In reinforcement plain concrete footing, the thickness at the edge shall be not less than 150 mm for footing on soil, not less than 300 mm above the top of the piles for footing on piles. In the clause 34.1.2 is saying that if your normal footing, I mean isolated footing or rough footing, in that case the edge value should be 150 mm. For pile cap, that means footing on the pile, that should be 300 mm. In the case plain concrete pedestal, the angle between plane passing through the bottom edge of the pedestal and the corresponding junction edge of the column with pedestal and the horizontal plane shall be governed by this tan alpha. So that means suppose this is your pedestal. Suppose ये आपका main, this is your main column. So these alpha, this is alpha, and that value is tan alpha not less than 0.9, tan alpha not less than 0.9 root over 100 qs by fck plus 1. What is q? And calculated maximum bearing pressure at the base of the pedestal. That is your bearing pressure. FCK, characteristic strength of concrete at 28. Now we talk about 34.2, that is moments and force. Resistance of this is main focus of us. In this case, footing on piles, computation for moment and shear may be based on the assumption that the reaction from any pile is concentrated at the center of the pile. Definitely. For the purpose of computing stress in footing which support a round or octagonal concrete column or pedestal, the face of the column or pedestal shall be taken as the side of the square inscribed within the perimeter round octagonal column pedestal. Bending moment. The bending moment at any section shall be determined by passing through the section of a vertical plane which extends completely across the footing and computing the moment of the force acting over the entire area of the footing on one side of the said plane. The greatest bending moment to be used in the design. Definitely, suppose you have the three value moment 100, 150, 200. So this should be your maximum. Okay, that's it. At the face of column pedestal wall for footing supporting a concrete column pedestal halfway between the center line and the edge of the wall for footing under masonry wall halfway between the face of column or pedestal and the edge of the gusset base for the footing under gusset. Shear and bond. The shear strength of footing is governed by the more severe of the following two conditions. The footing acting essentially as a wide beam with a potential diagonal crack extending in a plane across the entire width. The critical section for the condition shall be assumed as a vertical section located from the face of the column, pedestal or wall at a distance equal to the effective depth of footing for footing on piles. Two-way action of the footing with potential diagonal crack along the surface, truncated cone pyramid around the concentrated load according to the approach. So this is basically one way shear. This is your two-way shear test in the footing. If you remember the design section. In computing the external shear on any section through a footing supported on the pile, the entire reaction from any pile diameter d whose center is located d by d. Definitely. The critical section for checking the development length for the footing shall be assumed at the same plane as those described for bending moment in also at other vertical plane where abrupt changes of the section occur. If reinforcement is coupled, the anchor requirement shall be checked. Now talk about the tensile reinforcement. The total reinforcement section shall be provided dependent moment of resistance at least equal to the depth. Total tensile reinforcement shall be disturbed across the corresponding resistance section as given below. In a one-way reinforcement footing, the reinforcement extending in each direction shall be disturbed uniform across the full width of the footing. In two-way reinforcement square footing, the reinforcement exceeding in each direction shall be distributed uniform across full width of the footing. In two-way reinforcement rectangular footing, the reinforcement in the long direction shall be disturbed uniformly across the full width of the footing. For reinforcement in the short direction, a central band equal to the width of the footing shall be marked along the length of the footing and the portion of the reinforcement determined in the accordance with the equation given below shall be uniformly distributed across the central load. So that is the 2 by beta plus 1. Transfer load at the column base. The compressive stress concrete of a column pedestal shall be considered as being transferred bearing to the top supporting, that is, one is this A1 by A2 root over not greater than 2. A1 is your supporting area of bearing footing. A2 is the loaded area of the column base. The working stress method, so from here is, that is the WSM provision, taken as 0.25 FCK. For limit state method it is 0.45 FCK. So that is your limit state consideration, that is your LSM consideration, where the permissible bearing stress on the concrete in the supported member would be exceeded. Reinforcement shall be provided for developing the excess force either by extending the longitudinal bar into the supporting member or by dowels, where transfer of the force is accomplished by reinforcement. The development length of the reinforcement shall be sufficient to transfer the compression or tension to the supporting member in the accordance with this. Extended longitudinal reinforcement or dowel at least 0.5% cross-sectional area. The supported column or pedestal and a minimum of 4 bar shall be provided. Where dowel are used, their diameter shall not exceed diameter column more than 3 mm. Column bar of diameter larger than 36 mm in a compression only can be doweled at the footing with bar a smaller size of the necessary area. The dowel shall extend into a column a distance equal to the development length and the column bar into the footing a distance equal to the development length of the dowel. Nominal reinforcement. Minimum reinforcement spacing shall be as per requirement solid slab. That is the 0.12% and 0.15%. That depend on one for HYST, one for MST. The nominal reinforcement concrete section thickness greater than 1 meter shall be 360 mm square per meter length in each direction on each face. This provision does not supersede the requirement of the minimum tensile reinforcement based on depth of section. So here we ended the clause regarding footing. In next video we talk about the next part of the IS code. So hope you understand this whole video. If there is any kind of doubt, do comment in comment section. I will definitely get back to you. And yeah, feel free to ask any kind of doubt regarding civil engineering. And yeah, like, share, comment this video. Thank you for watching this video.